Welcome to Let's Talk Micro. Hello, everyone. Welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. And you can always find Let's Talk Micro on Apple Podcasts, Spotify, Amazon Music, Goodpods, TuneIn Radio. Wherever you listen to podcasts, you can find Let's Talk Micro. As far as social media, I am on Instagram, TikTok, and YouTube as Let's Talk Micro, on X as Let's Talk Micro 1, on LinkedIn as Luis Plaza, and I have an email address which is letstalkmicro@outlook.com. So either via social media or via email, you can submit any feedback, any possible topic suggestions. Those are always welcome and appreciated. And please go ahead and subscribe to the podcast, download episodes, and if the app allows you to do so, please go ahead and leave a review. As always, I am grateful for your support. And if you haven't checked out the previous episode, please go ahead and do so. It was a great episode with Lisa Parlich, which, she's a microbiologist turned infection preventionist at a hospital system in Illinois. I met her during ID Week, where she was presenting an oral abstract on a type of urine culture order that they implemented at her hospital system on a specific patient population. So it seemed very interesting, so I reached out to her. I actually saw her, during ID Week. After the presentation, we talked. I extended an invitation to the podcast, and she accepted. So it was a great conversation, and those of you that work in microbiology, you're familiar with the urinalysis with reflex to culture order, which means that if the urinalysis result is considered positive, it automatically reflexes to an urine culture. So Lisa talks about what the criteria for a positive urine culture is. She talks about this urinalysis with reflex to culture order. So we basically, we break it down, and then she talks about this urinalysis with hold panel, which means that if the urine is positive, it is placed on hold, and then the provider has about 48 hours to order an urine culture. And this is on the basis that a lot of times, maybe sometimes even patients have what's considered a positive urine, but they might not be experiencing any symptoms. And we get all these cultures order, and then we report organisms, and then there's a cascade of events where we report the organism, and then maybe it doesn't require susceptibilities, but then we get the request to perform susceptibilities. So we are putting all these results out there, and sometimes we might think, are we actually helping the patient? Right? The patient, being put on antibiotics, for that particular case, is that the correct choice? Are we contributing to AMR? I mean, we are not physicians, we're microbiologists, so we do the testing, we put the information out there, and then the physicians and the healthcare providers, they make that decision to treat the patient. So it seems that, with this type of order, we maybe are reducing the number of unnecessary cultures. And I think the goal is to maybe extend it to other patient populations. So it's, so far it seems to work well in her hospital system. So maybe this is something that you might be thinking about trying out in your hospital system. But overall, a great episode, great conversation. And it was great chatting with Lisa. She's a microbiologist, so she works in a large facility, just like I do. So she understands what it is, working with a lot of samples, all these requests that we are, we're putting all these results out there, and then we get requests for more susceptibilities, and a lot of times, we see susceptible profiles, and then we still get a request for one of these MDR, type antibiotics. So, we have all these factors. So I think that sometimes, if someone is able to contribute to reducing the number of unnecessary cultures, and at the same time, contributing to reducing AMR, I think that's a plus. So if you haven't checked out that episode, please go ahead and do so. So today's episode is about Streptococcus pneumoniae, and this is something that I have touched on before, but as the podcast grows and gets more listeners, sometimes, I like to replay older episodes because I don't think that, they didn't stand a chance back then. I publish weekly, and the growth of the podcast is, it's a steady growth, but a lot of times can be a little slow. So maybe some episodes they might have not gotten the traffic that they deserve because it is good material, it is good information. So today I am replaying an episode that was originally episode 57 from season 2, which is Streptococcus pneumoniae. I did some editing. As always, be mindful that as I progress in the podcasting world, I get better with the sound. So sometimes, there might be a little bit of a different sound here and there, but the content is great. So definitely I invite you to listen to this episode. And this was part of 2 episodes, 57, Streptococcus pneumoniae, and then episode 58, which was about strep pneumo and testing. So please go ahead and check them out if you haven't already. So in this episode, I go over the gram stain, I go over colony morphology, I talk about optochin, and I talked about the bile solubility test. So as I said before, great information, great content. So I hope you like it. And also definitely please share it with others. So let's go ahead and listen to this great episode about Streptococcus pneumoniae. So on today's episode, I want to talk about Streptococcus pneumoniae. So the last time I went over an organism, I talked about Enterococcus and VRE, which is vancomycin resistant Enterococcus. Those are episodes 53 and 54 of the last season. So go ahead and check them out if you haven't done so already. So let's go ahead and talk about Streptococcus pneumoniae or strep pneumo. So if you hear me saying strep pneumo, so it's Streptococcus pneumoniae. So this is a gram-positive cocci in pairs. It is definitely a serious organism. It is one of the leading causes of morbidity and mortality. It is the primary cause of community-associated pneumonia, meningitis, and otitis media. The last one being actually the most common infection seen with Streptococcus pneumoniae in children up to 3 years old. So what about pneumonia? So it causes 95% of all bacterial pneumonias. It is also the major cause of bacterial meningitis in the United States. And we're getting technical. It has a polysaccharide capsule that is associated with its virulence. The strains that are non-encapsulated are avirulent. So now that you're thinking about what would a colony that's encapsulated will look like on agar? Well, if you're thinking mucoid, then yes, you are correct. So Streptococcus pneumoniae, the strains that are encapsulated, they are mucoid on the agar. And of course, as a microbiologist, when you see this stuff on the on growing on media and you see the morphologies and stuff, I always find it fascinating. But it's not to say I always have the understanding that this is serious for a patient. But as a tech, when you see this stuff, you commit it to memory and you get more proficient. So we are excited in a way when we see organisms like this growing on agar because we can learn the morphologies, we can remember them, and it makes us better at our jobs. But we definitely know that this is serious for the patient. So seeing the stuff on plates growing, we get better at it because we start seeing them and we know them and incorporate it into our knowledge. But of course, it is serious for the patients. But yes, encapsulated strains, they tend to be mucoid. And that's also why it makes you think about Cryptococcus neoformans, right? That's encapsulated. And when you see it on the plate, it is mucoid. So you might not see a strain like this in your hospital, maybe, depending if you're a small facility. So you might see the QC strain, which is non-mucoid. But when you get it from a patient, sometimes you get these beautiful alpha hemolytic mucoid colonies. So strains that are encapsulated are virulent, and strains that are non-encapsulated, they are avirulent. And people might actually have it in their upper respiratory tract without it causing any harm. And according to Bailey and Scott's Diagnostic Microbiology, which is a great source that I mentioned in the podcast and that I use to get the information on these organisms. According to that book, there is a carriage rate of 5 to 75%. It can spread to the lungs, sinuses, and middle ear. And it can also access the bloodstream and the meninges. That's why, I mentioned that it causes meningitis. So if you work in a lab and you run a meningitis panel, you see that Streptococcus pneumoniae is one of the targets, right? In addition to other organisms, but you see it there. And that's the reason why you see it in this test. So Streptococcus pneumoniae also has pneumolysine, which is a cholesterol-dependent cytolysine. And this is a virulence factor that interferes with phagocytosis. It also has phosphorylcholine, which binds receptors for certain cells, helping the spread of the organism. There is a vaccine that helps in preventing infections, and I'm just mentioning it. I know that vaccination it's always a heated topic, but there is a vaccine for Streptococcus pneumoniae. And according to the Center for Disease Control and Prevention, which is the CDC, there are 2 types of vaccines available in the US. One is the pneumococcal conjugate vaccine, and the other one is the pneumococcal polysaccharide vaccine. For the criteria such as age, any medical conditions, and more, refer to the CDC's website. So now that we know the pathogenicity, let's go ahead and talk about colony morphology. So like I mentioned, it is a gram-positive cocci, and you see it in pairs. They are lancet-shaped. So this is good to remember if you're a student, and even if you're a professional in the field. And when I talk about identifying strep pneumo in samples, I will talk more about the gram stain and why this is something that you should remember. So, but if you're a student, they are lancet shaped, which are elongated, and you hear the term used, diplococci. It's something that you use, but typically, in labs that I have been in, you for gram-positive cocci, you just use gram-positive cocci in chains, in pairs and chains, clusters. So you might not use this term diplococci that much. So remember that it is lancet-shaped, gram-positive cocci in pairs. So as far as media, it grows on blood, chocolate, PEA. It is recommended that the plates are incubated in CO2, which typically, your respiratory samples, and when you have all these pathogens, when you have like your Neisseria, Haemophilus, you incubate it in CO2. And I mentioned this because, typically some facilities you have urine cultures that you incubate them in non-CO2. But for Streptococcus pneumoniae, which you might see it from a blood culture or a respiratory culture, typically, or an ear culture, so those they go on CO2. But this is the recommended atmosphere for Streptococcus pneumoniae. So the colonies are alpha hemolytic, and like I mentioned before, encapsulated strains are mucoid. It is optochin susceptible. And if you don't remember optochin, go ahead and check out episode 8 of this podcast. I go over optochin, but you remember that you have this disc, which is called the P disc, and then you inoculate your plate, you put it there, and Streptococcus pneumoniae is susceptible to optochin. So using, you measure the zone of inhibition, and susceptible is 14 millimeters or greater. This is something that you have to be careful about because sometimes people do leave the P disc outside for many hours and they might not work. And I have been breeding cultures where I see that you have a plate and they call it positive for P disc, which is susceptible, so they're calling it strep pneumo. But then if you measure the zone, you might have 12 or 13. And you shouldn't be calling it Streptococcus pneumoniae if you have a zone of 12 or 13 without actually performing a method of ID, such as Molotov, Vitek, etc. Because you might have a Streptococcus mitis or another alpha strep which are resistant to optochin. So if you are reading cultures and you have an optochin disc and you measure is 12 or 13, you need to do an ID on it. But Streptococcus pneumoniae, it's susceptible to optochin and you need a zone of 14 millimeters or greater. This organism is a strep, so it's catalase negative. But there's also tests, you can identify it using, like I mentioned, Vitek, Molotov. There are some tests out there that I will talk about in the next episode to identify strep pneumo. But however, there is a test that this is classic, and if you're a student, you might go over it, and maybe in your lab, because I know sometimes, maybe not in the US, but in other parts of the world, you still do a lot of manual tests. So there is a classic test that it is used in helping, identify strep pneumo, and this is called the bile solubility test. Bile solubility test. So what is the bile solubility test? So this is a test that is used to differentiate strep pneumo from other alpha strep. Strep pneumo is soluble in it, and other alpha hemolytic strep are not. The principle of this test is that a bile salt lyses strep pneumo colonies, and this is dependent on amidase, which is an intracellular autolytic enzyme. So how do bile salts do this? Well, they lower the tension between the bacterial cell membrane and the medium, and this actually accelerates the autolytic process. So how is the test performed? Well, you grow the colonies on blood agar. If you have a pure culture and the time, which is 24 hours or younger, you can go ahead and perform it. But if not, if you have just a few colonies, you sub it to a blood agar plate, and then you go ahead and incubate it, and then the next day you go ahead and perform the test. So what you do is, once you have your colonies on blood agar, you place a few drops of a 10% deoxycholate solution, which is a bile salt, on a colony and incubate the plate in non-CO2 at 35 to 37 degrees for 30 minutes. The colonies of strep pneumo, they are lysed, and this leaves an imprint of the colony. Other alpha hemolytic strep, they do not lyse, and the colonies remain intact. So this is called the spot method. There is also a 2% solution, and companies, like Fisher, they sell both solutions, and according to their site, the 10% may provide more rapid reactions. But both solutions have been tested and they work well. So you have that spot test, you have your colonies, you add your solution, and then you incubate for 30 minutes, and then the colonies are lysed. So that's a positive test for bile solubility. So there's also a method, which is the tube method. And for the tube method, you prepare a 0.5 McFarland suspension of the suspect colonies. Then you split it in equal parts to 2 tubes. In one of them, you add 0.5 ml of the deoxycholate solution. And the other tube, you leave as is. And do you know why this is? Well, if you're thinking that because it is used as a control, then you are correct, right? So you have one tube where you add in the solution and the other one you don't touch, so you can compare, right? Because you shouldn't see any change on the tube that doesn't have the solution. So once you do this, you incubate both tubes, same temperature, 35 to 37 degrees, and non-CO2, and then you check up periodically for up to 3 hours. A positive test shows clearing in the tube, and what's this? This is lysis. Whereas the control, or a negative test, remains turbid. And keep in mind that this is an enzymatic reaction. So like I mentioned, you need older colonies might give erroneous reactions, inaccurate reactions. So it is recommended that, you need a 24-hour culture or younger. And this not only applies to enzymatic reactions, this applies to susceptibilities and other tests. You don't want all colonies because sometimes, the reactions might not be accurate. So when you're doing any type of workup, any type of setting, setup for any type of test, you always need a fresh culture, which is an 18 to 24-hour culture. So there you have it. You have 2 methods, the spot method where you add the deoxycholine solution directly to the colony, or you have the tube method where you prepare a suspension and then you add the solution to it. So they both require being incubated at 35 to 37 degrees in a non-CO2 incubator. So to summarize, Streptococcus pneumoniae, a very serious organism. It is, seen in otitis media, meningitis, pneumonia, and also, there's a vaccination for it if you want it. And then it is an alpha hemolytic, gram-positive cocci in pairs. And remember that morphology, committed to memory, because typically, the streps, you see the long chains or you see the short chains, but this one is lancet-shaped and it occurs in pairs. So remember that. It's a strep, so it's catalase negative. It is optochin susceptible. And if you haven't learned about optochin, or if you want a refresher, go ahead and check out episode 8 of this podcast. And it is soluble to bile, meaning that it will, the colonies, they will lyse in the presence of bile. And this test, can be done by two methods, can be performed by two methods, which are the tube and the spot method. And that, my dear audience, it's the end of this episode. I hope you enjoy learning about Streptococcus pneumoniae. As always, I enjoy sharing this information with you. And if you haven't checked out the original series, episodes 57 and 58, on 58, I go over testing as well. So please check it out if you haven't already. As always, thank you for the support. Those of you that are actually been waiting for another AMR sub-series episode, stay tuned. It's coming closer than you think. So please hang on and stand by. So please continue bringing that passion to what you do. It's so important. You do such great work. As always, I'm grateful for the support. And please stay motivated. Stay safe, and of course, continue talking micro. Until the next time, bye.